Hello again. This is Math 0482, and this is a September 5th contribution, the second contribution on 9-5, and the topic of this lecture is variation. We will consider here four types of variation problems that are very significant in both math and the sciences. In this lecture, you will learn to distinguish between the types of problems, the types of variation problems, and learn how to solve them. We will discuss in turn direct variation, inverse variation, joint variation, and combined variation. Examples of each are worked through, and you-try problems with answers are provided to help you learn. Let's begin with the definition of direct variation. Y varies directly as x, or y is directly proportional to x, means y is equal to kx, where k is a non-zero real number. K is called the constant of variation. If two quantities vary directly and k is bigger than 0, then as one quantity increases, the other increases as well. And as one quantity decreases, the other decreases. In examples we have talked about before of driving distances, y equals 60x, 60 is a constant of variation. Given information on how variables are related, we can write an equation and solve a variation problem. Let's do an example. Suppose y varies directly as x. Right away, when I tell you that y varies directly as x, you know that y is equal to k times x. Then I give you some data. If y equals 18 when x is equal to 3, we can find the constant of variation. That's part A. Part B, we can write a variation equation relating x and y using the value of k that we already found. And then we can use that general equation to find y when x is equal to 11 in this problem. In fact, we can find y when x is equal to any value. So let's solve part A. So to find the constant of variation, we write a general variation equation relating x and y. Since y varies directly as x, that means that y is equal to k times x. We are told that y is 18 when x is equal to 3. So we substitute these values into the equation and solve for k. So y equal kx, that means 18 is equal to k times 3. Dividing both sides by 3, we find that k is equal to 6. That means that the specific variation equation is the equation obtained when we substitute 6 for k in y equal kx. Therefore, the specific variation equation is y is equal to 6x. Now for part C, then, we know y is equal to 6x, so to find y when x is 11, we substitute 11 in for x into the equation y equals 6x and evaluate. So y equals 6x. When we substitute 11 for x, we get y is equal to 66. So, in general, the procedure for solving a variation problem, any of our variation problems, is you write the general variation equation. That's step 1. Step 2, you find k by substituting the known values, the data, into the equation and solving for k. Step 3 always involves writing the specific variation equation by substituting the value of k into the general variation equation. And step 4, we use the specific variation equation to solve the problem. Now here is a you-try similar to the one that we just talked about for you to do. Suppose y varies directly as x. If y is 40 when x is 5, part A, find the constant of variation. Part B, write the specific variation equation relating x and y. And part C, find y when x is equal to 3. Please pause the video, try to solve it, and then resume the video. I'm pausing the video now. Let's see how you did. And so the answer you should have gotten is the constant of variation was 8. The specific variation equation relating x and y is y equals 8x, and y, when x is 3, is 24. Now we turn our attention to solving inverse variation problems. If two quantities vary inversely, parentheses, are inversely proportional is another way to say that, then as one value increases, the other decreases. Likely, as one value decreases, the other increases. Here's the definition of inverse variation. Y varies inversely as x, or y is inversely proportional to x, means y is equal to k over x. Notice that y is in the numerator and x is in the denominator, where k is a non-zero real number. Again, k is called the constant of variation. A good example of inverse variation is the relationship between the time it takes to travel a given distance as a function of the rate or speed. You see, we can define this relationship as t equal d over r. So as the rate r increases, the time t that it takes to travel d miles decreases. Likewise, as r decreases, the time t that it takes to travel d miles increases. Therefore, t varies inversely as r. Let's work through an example. Suppose q varies inversely as h. If q equal 4 when h is equal 15, find q when h is equal to 10. Step 1, we write the general variation equation. Now, since it told us that it varies inversely, we know that q is equal to k divided by h, k over h. Step 2, we're going to find, using the known values, q equal 4. When h is equal to 15, we'll say q is equal to k over h. That is 4 is equal to k over 15. That tells us that k is equal to 60. So now we have this specific variation equation that q is equal to 60 over h. Step 3 is we substitute k equals 60 in there, and we know q is equal to 60 over h. But then the question asks us what was q when h was 10, so we substitute 10 into the equation q equals 60 over h to find q. So q is equal to 60 over 10, or 6. Here's a you try problem for you to try. Please pause the video after this, work it, and compare notes. Suppose m varies inversely as the square of v. If m equal 15 when v equal 4, find m when v equal 2. Note that this was m varies inversely as the square of v. That means m is equal to k over v squared. Pause the video and try to solve it. Let's see how you did. And the answer to this you try is that m should be 6. Now we will turn our attention to solving joint variation problems. If a variable varies directly as the product of two or more variables, the first variable is said to vary jointly as the other variables. Said more with equations rather than words. Y varies jointly as x and z means that y is equal to k times xz, where k is a non-zero real number. Again, it's a constant of the variation. Here's an example. For a given amount invested in a bank account, and this is called the principal, the interest earned varies jointly as the interest rate, expressed as a decimal, the time the principal is in the account. Okay, so if Graham earns $80 in interest when he invests his money for 1 year at 4%, how much interest would the same principal earn if he invested it at 5% for 2 years. And by the way, this is known as simple interest. And we're going to define variables here. We're going to let R equal the interest rate as a decimal. We're going to let T equal the number of years the principal is invested, and I is the interest earned. The interest rate is also a decimal per year in this scenario. Okay, so we can write the general variation equation from the words we had before. It's varying jointly. So I is equal to K RT. Now we know that I is 80 when T is equal to 1 and R is equal to 0.04. And so we can find out what K is. I is equal to K RT. That means substituting the values that 80 is equal to K times 0.04 times 1. Doing the calculation, we get 80 is equal to 0.04 K. We divide by 0.04 both sides and we find that K is 2,000. And that means the amount he invested, the principal, was 2,000. So K was 2,000. That means that the very specific variation equation is I is equal to 2,000 times R times T. So step 4, we want to find the interest that he will earn if $2,000 was invested at 5% for 2 years. Well, here R is 0.05 and T is 2. And so we substitute in our general equation I is equal to 2,000 RT. We substitute for R and T. So I is equal to 2,000 times 0.05 times 2. You do the calculation, you get 200. That is, the interest that Graham would earn over the 2 years is $200. Here's the U-try for the same concept. The volume of a box of constant height varies jointly as its length and width. A box with a volume of 9 cubic feet has a length of 3 and the width of 2. Find the volume of a box with the same height if its length is 4 and its width is 3 feet. 4 feet and 3 feet. Length is 4 feet, width is 3 feet. Please pause the video, give this a try, and come back for the answer. Let's see how you did. And the answer to this one is 18 cubic feet. The last kind of problem that we will encounter in this lecture is we will solve combined variation problems. A combined variation problem involves both direct and indirect variation. And let's talk about an example. Again, one must read carefully. So suppose y varies directly as the square root of x and inversely as z. If y is 12 when x is 36 and z equal 5, find y when x is 81 and z equal 15. Well, step 1 is we write the general variation equation. Since y varies directly as the square root of x, y is in the numerator on one side, but the square root of x is with k on the other side. Since y varies inversely as z, z is in the denominator. So the equation, the general variation equation here, is y is equal to k square root of x in the numerator, all divided by z. Now we're going to use the known data, y equal 12 when x is 36 and z equal 5, to figure out what k is. So we will substitute those values into our general variation equation. And so we will say 12 is equal to k square root of 36 divided by 5. And we can solve for k and realize that we can multiply both sides by 5 and the square root of 36 is 6. So we get 60 is equal to 6k, and that means that k is 10. Now we can move to step 3 because now we know the specific variation equation. Y is equal to 10, the square root of x over z. And then step 4, they ask us to find y when x is 81 and z is 15. Well, we just substitute this 81 for x and 15 for z. So we get y is equal to, we now know that k was 10, so y is equal to 10 times the square root of 81, all divided by 15. The square root of 81 is 9, so we get 90 over 15, and so y is 6. Now here's another you try for you to try. Suppose a varies directly as b and inversely as the square of c. If a equal 28 when b equal 12 and c equal 3, find a when b is equal to 36 and c equal 4. Give it a go, please, and come back when you're finished. Let's see how you did. And the answer you should have gotten for that was 47.25 as a decimal, or 47 and 1/4 otherwise. In closing, remember, time is precious. Each day must count. Do the math. It will make you strong. Look forward to seeing you soon. Take care.